Hello friends, I welcome you all in the world of mathematics. I am Atul Kumar, your maths faculty. And today I will talk about Lagrange's mean value theorem. It is an important theorem in calculus. Okay, so let's try to understand it. Lagrange's mean value theorem. What's the statement of the theorem? Let fx be a function from closed interval ab to r, and let fx be continuous function on closed interval ab, differentiable on open interval ab. Okay, if these two conditions are satisfied, then there exists some c in open interval ab such that f dash c is equal to fb minus fa divided by b minus a. Let's try to understand it with an example. Okay, we will take very simple example here. Let's consider a function. Consider fx is equal to x square plus x plus 1 in closed interval 0 to 1, right? There's no doubt at all that it is defined in this closed interval and it is a real valued function. Kyun? Because polynomial functions are continuous and differentiable on entire number line, right? So f is continuous on closed interval 0 1, right? Differentiable in open interval 0 1. Let's try to draw the graph. It is y-axis, it is our x-axis, and at 0, f0 is how much? F0 is 1, f1 is 3, and the graph is upward concave parabola, so it goes like this. Right. Now let's join these points. This point is 1 3, and this is 0 1. Okay, what is f dash x? Let's calculate. It's 2x plus 1. Okay, therefore what is f dash c? F dash c is 2c plus 1. Let's calculate f3 minus f1 divided by f3 minus f0 divided by f1. Our endpoints are 0 and 1, right? So we will calculate f1 minus f0 divided by 1 minus 0, that is 3 minus 1 divided by 1 minus 0, that is 2 by 1, that is 2. Okay, if f dash c is equal to 2, this implies 2c plus 1 is equal to 2. This implies 2c is equal to 1. This implies c is equal to 1 by 2. Okay. Where is this 1 by 2? This 1 by 2 is in open interval 0, 1. Okay. In open interval 0, 1. And f dash 1 by 2 is nothing but f1 minus f0 divided by 1 minus 0. Okay. Both of these are how much? Both of these are 2. Okay. We can understand by the graph also. There is a point. This is 0 and this is 1. There is point 1 by 2. At this point, the tangent is parallel to the secant. That's the meaning of f dash 1 by 2 means f dash 1 by 2 is the slope of tangent drawn at 1 by x equal to 1 by 2. Okay. And this slope is equal to slope of the secant joining point 0, 1 and 1, 3. The slope of secant joining these 2 points 0, 1 and 1, 3 is parallel to is equal to slope of the tangent drawn at point 1 by 2, x equal to 1 by 2, right? So this is the whole meaning of Lagrange's mean value theorem. If in a closed interval, in a given closed interval, a function is continuous, and in the concerned open interval it is differentiable, then there is a point C in that open interval where the derivative, where the tangent drawn is parallel to the secant joining the endpoints. So from this example, we have understood what is the meaning of Lagrange's mean value theorem. This is applicable, widely applicable in calculus. This is very important property, and it is a very beautiful property. It is just an observation, and that observation has been put into words in the form of Lagrange's mean value theorem. Okay, we can have another example. We have to verify Lagrange's mean value theorem for function fx equal to log x in closed interval 1e. Friends, let us try to understand. Fx log x. Log x is continuous in its domain. We will draw the graph. Just see here. This is y-axis, this is x-axis. Fx equal to log x. This log is to the base e. This is a continuous function. Actually, the domain of log of x is open interval 0 to infinity. It is defined in this open interval. So this function is defined certainly in closed interval 1e. Also this function log x is undoubtedly continuous in closed interval 1e. The graph is everywhere smooth, everywhere we can draw the tangent. Therefore, this function log x to the base e is differentiable in open interval 1 to e. At every point in open interval 1e, a tangent can be drawn on the graph. Okay, so the two conditions are satisfied in this interval 1 to e. Now what is f dash x? F dash x is 1 by x. Okay, this implies f dash c is 1 by c. Fine. Now, fb minus fa divided by b minus a. What is b? Our b is e. Our a is 1. So fb minus fa divided by b minus a means f1 minus fe fe minus f1 divided by e minus 1. Right? What is fe? What is log of e? It is 1. What is log of 1? It is 0. So 1 minus 0 divided by e minus 1. That is 1 divided by e minus 1. Fine. If f dash c is equal to this value, fb minus fa divided by b minus a, that means 1 by c is equal to 1 by e minus 1. Therefore, c is equal to e minus 1. Right? This point is 1 and this point is, e. So, this point on the graph is e1 and this point on the graph is 1, 0. Where is point e minus 1? Friends, understand what is e? E is a number between 3 and 2. So e minus 1 is between 1 and 2. But 2 is less than e. Therefore, e minus 1 is less than e and greater than 1. Okay. So in this graph, e minus 1 is a point between 1 and e, where if you draw a tangent, that tangent would be parallel to the secant joining 1, 0 and e1. Okay, and that's the meaning. So we can boldly say that mean value theorem, Lagrange mean value theorem, is satisfied for this given function. Okay, this is a very beautiful function. Log x is a very, very popular function. It is differentiable and continuous in its domain. Okay, and that's why we have seen our discussion was within the interval 1e, and in this interval, closed interval 1v, we have analyzed deeply here, and we have seen that Lagrange's mean value theorem is valid. Okay, thank you very much.